That's why I wrote the following inequalities for a problem that she was solving. She wrote down 2n minus 1 is less than 5, and then or 2n minus 1 is greater than negative 5. Which of the following statements is true? So if I look at each one of these individually and solve them, on this one I could take, just considering the boundary, 2n and would be greater than 6, and then less than 6, and then therefore n would have to be less than 3. And then I've got or joining those, so I'm going to have 2n is greater than, if I add 1 to both sides of that, that's going to become negative 4. And then if I divide both sides by 2, I'm going to get that n is greater than, that would be negative 2. So we should have n is greater than negative 2, or n is less than 3. I think it should be D. Now you'll notice that I did not find the boundary point and then test above or below. I just basically kind of ignored the fact that they were inequalities, and I'm doing that because I'm aware of one difficulty that arises, and I don't think that difficulty is here. We'll talk about that more in class. But if I was to set these as equations, this would be n is 3, that's the boundary point, and this would be n is negative 2. And now that I've identified those boundaries, I need to think about, okay, this is way over at 3. Here's 0, 1, 2, 3. I'm saying that it's less than 3, so that means 0 should work. And when I plug 0 into this inequality for n, it does give me negative 1 is less than 5. So that's true. This is one end of this. Now the other one, on a number line, here's negative 2, here's negative 1, and here's 0. When I plug that 0 into that inequality, when I plug 0 into that, I get negative 1 is greater than negative 5. That's true also, isn't it? Yeah. So the boundary there was negative 2, and it was an open boundary, and it goes this direction. So yeah, n is greater than negative 2, so this is true also. So the one inequality that matches that is D. Nice.